Hello, my friends. How are we all doing today? Can you tell where I'm at? If you can read, you can. I can sometimes not read, but if you read, you can. This is the quality policy here at Jergens. And today we're going to talk all about quality with my buddy Shawn. In fact, just behind my camera people here, Shawn is waiting for us in front of this beautiful blue Matsuura. Shawn, quality is the subject of the day. You, my friend, are quality. The audience is quality. So let's get into these nuts and bolts. Man, that's another bad dad joke. I'm sorry, guys, but I have to do it. Quality. We're starting here with Matsuura. Everyone knows precision, accuracy, reliability, but there's more to it here.
Absolutely.
You guys actually have some software making sure that this young man knows exactly what's happening with every single part that comes off the machine. Can we talk about that?
Absolutely. So today we're looking at the Matsuura. We have a program we call QC Calc that runs in the background while the operator's running the machine. So as he's machining each feature, there's a little probe that will touch off on there, measure that feature, and then display it on a screen so he can reference it very quickly and see where he's at.
And by doing this, I'm gonna be Captain Obvious. I love being Captain Obvious, actually, because I think it matters when the audience is listening to go, well, I would have asked that question, or maybe it's just too simple. Regardless, what is this software doing for all the components? Reducing scrap, creating efficiency, making sure that quality that you're looking for is in every single part with that reduction. What are we encompassing by utilizing something like this?
We're reducing variation from feature to feature. So if we're making a hole on a part, we want that hole to stay consistent because it might be a critical feature for our customers to use. Say they're using it to locate something on one of their machines. Well, it's really important that that hole stays the same size from part to part. So again, if they're using a different part from us, the same feature, it's going to be the same across the board.
Well said, Shawn, and I wanted you to say that because as we bounce around your shop today, your factory today, we are focusing on the customer.
Yes.
We are saying the quality that's being done here at Jergens is for them. And of course we want to be able to sell a quality product. It's easier than making things up and smoking mirrors, which some people out there do. But
Absolutely.
here at Jergens, where doors are open, transparent, showing quality. I mean, I look at the back of your shirt, 1942, you've kind of been doing it a long time, right?
And quality's been part of it since day one.
Yeah, quality has been part of it, as well as community service. If I'm gonna just throw that out there for you a little bit, as well as community service and supporting everything. Is there anything that you'd like to cover in this area before we bounce over to this really cool automation cell for the audience?
Again, we're not only using QC Calc to measure our parts. We have all sorts of gauges that are calibrated on a periodic time frame that makes sure that when the operator uses them, they are saying what they're supposed to say. They can use them in unison with the QC Calc to verify measurements, and then we could take that data and even drill down further, create capability studies on it, show features that are specific to what we need the component to do. So again, we can look at it, yes, from the machine, but we can also take that data and really drill down on it, improve our processes through data collection, capability studies, sharing that information with our engineering team and allowing them to kind of digest it and see what's going on with those features on a daily basis. So we just get better and better every time we run a part.
So speaking of drilling down and talking about that, stay to the end of this because we'll be in a room where we get maybe smash some stuff, or at least see how well it can hold up, because You're right. That's the point of every part of this process. Let's walk over to the next cell and talk about the automated situation you guys have going on there, right?
Yep.
All right, guys, we've made it over to the second cell. Maybe you saw our cool walks on the way here, a little bit of an Egyptian walk, but that's how we entertain ourselves in between these cuts that we do in this factory tour. We're looking at a full automation cell. I see a Fennec robot. So let's talk about the process of what's going on inside here, Shawn.
Yeah, so we make all these components on all of our other machines, then we bring them all together to fully assemble them into what we call our quick lock pin system. This cell here does it automatically. So we're loading the parts in. The robot picks those parts off, assembles them together, but as it's assembling them, it's also checking them for critical dimensions, making sure our torque values are correct, the dimensions that are critical to what our customer's application is. So again, this automatically checks all of those things for us. That way we don't have to waste more time doing it by hand, maybe taking up more valuable time for our customer when they were talking about on-time delivery. This thing does it all for us, and it's just an extra measure we put in place to make sure the parts get to our customers correctly and that they are for their correct application and they don't have any issues with them. Sorry,
That makes sense to me.
Yeah.
But I'm gonna put on my Captain Obvious cape
Sure.
again, right? Because, well, I have to. It's fun. It also makes people go, I could do that better than you, Tony, and maybe they can. But at least it gives everyone an opportunity. When we're set up here, we have a couple of buckets over here. We have red. They're color coded.
Yes.
Right. Every part of this process is tested, retested, checked to make sure it's good quality. And you even have a couple of different bins if one is good and one is bad. And if we look in this bin over here, just for fun, we have nothing in the scrap bin, just so you know, and only positives. So we know that this entire cell is set up for quality. What I want to do now, if it's okay with you, Shawn, is continue to talk about how this supports your customer. Okay. Now, I have definitely over-torqued something in my machining career. I have bent material when I shouldn't have, and I've left it too loose, and parts have flown out.
Yes.
So having this type of understanding of where it's supposed to be is very important. So
Crucial.
what you're doing, crucial is the exact word. So let's focus again on the customers and how this area is supporting quality of Jergens, but the quality of their production.
Sure. So again, the application for these pins is to hold something in place, right? So the handle has to be on properly. We can't have this coming off because then it fails. So what our machine is doing, it's applying glue around the threaded area of this handle. And that way, even after we torque it, that glue is going to secure that handle. And there's a little camera in this system here that will actually check the glue using infrared light, or I mean a black light. And then once this pulls out from that, it can go to the next station. So this overall length here is also very crucial. So if it's too long, there'll be slopping, and if it's too short, it won't lock in place what the customer's looking for. So checks that, and then finally it's going to check this dimension here, this B dimension, which is the ball bearing length. So if that dimension isn't correct, this thing will slide right out of the application. So it's important that all these things work together to get that part to the customer, so there is no question that it won't work.
Another one of those places where length matters, right?
Exactly.
Thought I'd get you with that joke. Can we head over to the next cell? One of my favorite areas with this gorgeous DMG MORI machine.
Absolutely.
Come on, guys, let's take a look. All right, Mr. Quality Assurance Manager. We're now standing in front of one of my favorite machines, the DMG MORI. We have an automated cell. I've actually had a video in the past with our buddy Matt on this same machine, but we took it in a different direction. Today, it's all about quality.
Yes.
What's going on here when we're focusing on quality?
So this machine's making parts for our ball lock plates. It's one of our older lines, one of our more successful lines, and something that we got to the market before anybody else. So we really take pride in this line, and we want to make sure every single part that comes off of this goes to the customer, no issue, and it works flawlessly. So we set up this machine to basically take measurements on all the parts as they're going through the system. And as it's taking the measurement of the OD and the ID, it can make adjustments automatically to the system. So if the grinding wheel needs to come in a little bit, we need to change a setup on something, the machine does it automatically. We have no question about what's coming off this machine, and every part is the same as the part prior. So again, it's crucial that these things work well together. The idea of this is what kind of lines the part up for the quick lock or ball lock assemblies, so that it has to slip in perfectly every single time and lock in place. Again, repeatability is the key word here. Every part that comes off here went through the same exact process, has almost the exact same dimensions called out on it, and the variance between part to part is nil. We actually have air gauges over here that the operator can use. We'll measure the ID and OD down to the 20 millionths. So very, very small tolerances on this, and it's crucial that we pick them up accurately every single time.
All right, Shawn, so do-si-do with me a little bit. One step forward, two steps back, that kind of thing, right? Let's talk about, you mentioned it's one of your original or conceptualized ideas from a while back, the ball lock system, right?
Yes.
Let's talk about the ball lock system for someone who might, just might be going, what is that to begin with? And then let's segue into what happens if it's not perfected as you just described.
Absolutely. Okay, well, the ball lock system is a plate that you would essentially use for machining. So you want to use it as a fixture plate where you're going to locate something onto a plate, and then your machine's going to come down and machine that part, right? So if it's shifted over a little bit, or this one's a little bit looser than this one, and there's movement in the fixture itself, it can cause the dimensions you're trying to hit to go way out. And again, that's the critical aspect of these things, is that it's repeatable. It gives that repeatability to our customer. That way, when they're running their processes, they know that a Jergens part is in there, and it's going to come out the same way every single time.
it must be incredibly frustrating to put one part in, a second part in an hour later, a third part in an hour later, and have 3 different parts. That's the kind of quality we need.
Yes. Well, that's why they hire a guy like me to measure
exactly
those
right.
things.
So can we slide over, maybe mash some things at this point?
We'll do our best.
So the 4th part of our tour, my friends, we're going to look at how they actually take first step, second step, third step, and it's a whole lot of steps we didn't get to today to make sure that your vices, when you have them, they really put pressure on them to make sure you're getting the quality that this quality assurance manager has all described along this journey so far. So shall we take a walk?
Absolutely.
Should we take a cool walk?
We'll do our best.
Okay. All right, Shawn, we've made it into the Jet Lab. We started off in front of the Matsuura, where I promised we might get to move some things, potentially see how strong these guys are, right? Mm-hmm. So we're in the Jet Lab now. Let's talk about what goes on in here. There's another good-looking young man in here just putting in work today. Does he want to be on camera? Oh, yeah, look, he's into it. He's into it. All right. So what's going on in here, Shawn?
Okay, so, speaking of the Matsuura, these are some of the parts that will be run on the Matsuura. This is part of our 5-axis group, our work holdings group, I should say. So what we're doing here is cycle testing. So when we sell these parts to a customer, we talk about repeatability and accuracy of their machining techniques and what we put into these products. Well, the other thing is they need to last a long time. So what we're going to do here is cycle the part over and over and over again to what we would consider maximum life, maybe even further than that. And we can provide that data to the customer and say, hey, if you buy one of our vices, it's going to outlast all of our competition. You're going to be using these things for years to come, and the accuracy will remain because of how well we made it, and it will also last any kind of issues you may see.
Shawn, I think this is important to understand, and I'm going to take a perspective real quick and do a flashback like I do sometimes about my machining days when I just started, and if I'm being honest, maybe I had a day where I didn't care. And I didn't own any of the equipment. And so what you're testing here would be against people like me when I was starting out as a machinist and I was over torquing and just maybe taking a mallet and smacking it to get it to unlock. And I was never spraying WD, so I was getting rusty. So what you're testing here, in my opinion, is maybe the conditions that can be the most difficult. Because Absolutely. We can always take care of something, and it's good. You can take care of a car that's a piece of rubbish, and it'll last a long time if you take good care of it. But the quality really comes in detrimental environments, in rough environments, in harsh environments, which the stereotypical theme about manufacturing is dull, dark, dirty, dangerous, all these things, which aren't true, my friends. It's an amazing industry, but that is the stereotype, and what you're testing here, I think, is incredibly important.
Yeah, again, we know all of our customers are going to be using these in different applications, but if you think about the machining application as a whole, you have oils, you have coolants, you have chips, you have all this debris that's going to be affecting these vices, and it's crucial that they function the same way every single time. So that's what we're building these things about. If a chip gets in here, it's going to be able to still work the same way as it did if it wasn't in there. If we have an issue with possibly lubrication being not correct, again, these things are built to last. That's the importance of our product. We want repeatability and want these things to last, and we want our customers to tell everybody else about how well they do. Oh, they repeat great, they lasted forever. That's what we're building. We're building a quality product here.
Quality. Quality is the name of the game. Quality is what we wanted to discuss today. Quality assurance. Man, I mean, the word, if we were at Pee-wee's Playhouse right now, we'd be going, screaming. That's the word of the day. So we are going to close out with quality here in this room. This is where we test the parts. But what I'm going to do is just kind of fun for the audience right now. If we could turn the camera and just ask this young man, do you like your job, my friend? Let's do it a little louder. I'm going to give him a lapel mic. How do you like it?
Oh, I love my job.
Yeah, he does. Loves the Jergens job right here. Appreciate you, man. I know we kind of threw you on the spot. All right, my friends, thank you all for watching. This is a Jergens factory tour focused on quality. There's definitely more coming soon. If you point the camera over at Chris here, he's the one of the marketing folks here at Jergens helping us out with cameras today. And also look for his videos where you'll get to see more of the inside of what's happening here at Jergens. And let me turn you back again. 1942. Yeah, it's tough to beat, man. Absolutely incredible U.S. made manufacturing right here. We appreciate you all watching.